Let's look at OpenStax College Physics, Chapter 13, Problem 37. A. What is the gauge pressure in a 25 degrees Celsius car tire containing 3.6 mole of gas in a 30-liter volume? B. What will its gauge pressure be if you add 1 liter of gas originally at atmospheric pressure and 25 degrees Celsius? Assume the temperature returns to 25 degrees Celsius and the volume remains constant. All right, so let's write down our knowns and unknowns. I don't think a diagram of a tire would be very helpful, so I'm going to skip that. But first, we know that the temperature is 25 degrees Celsius. And we know that we have to convert that into Kelvin, so that is 273 plus 25.0, so that's 298 Kelvin. All right, the tire contains 3.6 moles of gas, so N is 3.60 moles, and the volume of gas is 30.0 liters. We have to convert that to cubic meters, so that is 30.0 times 10 to the negative third cubic meters. So in part A, we're looking for the gauge pressure, P sub G. And then we know that for part B, we are adding, I'm going to call it a delta V of 1.00 liters. So that is 1.00 times 10 to the negative 3 cubic meters at atmospheric pressure. So P is 1.013 times 10 to the 5th pascals and 25 degrees Celsius. So we're looking for the new gauge pressure. So for part B, we want another gauge pressure when we've added some gas to the tire. All right, so we can start out with the ideal gas law. So PV equals nRT. And here we're looking for the pressure. That will be nRT divided by volume. And that is 3.60 moles times R, which is 8.314, times temperature, which is 298 Kelvin, divided by the volume, and that is 30.0 times 10 to the negative 3 cubic meters. When we plug these numbers into our calculator, we end up with 2.97 times 10 to the 5th pascals. But the problem is asking us for the gauge pressure. So the gauge pressure is this pressure that we obtained here minus the atmospheric pressure. So that is 2.97 times 10 to the 5th pascals minus 1.013 times 10 to the 5th pascals. So we end up with 1.96 times 10 to the 5th pascals for the gauge pressure in the tire. Now in part B, we are adding some gas, and we know that the pressure, that's the atmospheric pressure at which we are adding the gas, times the amount of gas we're adding, is going to be the delta N, the amount of moles that we're adding, times RT. So again, here I have, this is my number of moles that I have to figure out based on the fact that the gas is at atmospheric pressure and we're adding 1 liter or 1 times 10 to the negative 3 cubic meters of gas at 25 degrees Celsius. So we're going to be solving for this extra number of moles. So the delta N will then be P delta V divided by RT. So we know that that gas is at atmospheric pressure, so that is 1.013 times 10 to the 5th. The delta V, the amount of gas we're adding, is 1.00 times 10 to the negative 3 cubic meters. divide that by 8.314, that's the universal gas constant, and the temperature is 25 degrees Celsius or 298 Kelvin. So the number of moles that we're adding is 4.09 times 10 to the negative 2 moles. So what that means is that when we're calculating the new pressure, we have to use not just the n that we had before, but n plus delta n. So I'm basically recopying this equation. I solved for P here from the ideal gas law, but instead of n, I'm going to use n plus delta n. And then I have RT and the volume. So this will be 3.6409. So that's the new number of moles times R 8.314 times 298 Kelvin divided by 30 times 10 to the negative 3 cubic meters. And when we plug these numbers in, we end up with 3.007 times 10 to the 5th pascals. So again, to find the gauge pressure, we have to subtract from the value we just obtained the atmospheric pressure, which is 1.013 times 10 to the 5th, and end up with 1.994 times 10 to the 5th pascals.